Right now, 93 million miles away, a storm is brewing. This isn't a storm of wind or rain, though. It's a tempest of tangled magnetic fields and superheated plasma, and it's slowly turning to face us. Our star, the sun, the very thing that gives us life, is waking up. It's reaching the explosive peak of its 11-year cycle, and it's already given us a taste of its power. A recent monster flare lashed out, causing widespread radio blackouts across entire continents. That was a warning shot. Now, scientists are tracking a huge volatile sunspot region as it rotates toward Earth. They're holding their breath, bracing for what it might do next. The sun might look like a steady, peaceful ball in the sky, but it's actually a dynamic, violent, and often unpredictable nuclear furnace. For the past few years, its activity has been ramping up in a process called solar cycle 25. This is a totally natural 11-year cycle where the sun's magnetic poles flip. This causes it to go from a period of quiet called the solar minimum to a peak of chaotic activity, the solar maximum. And we are entering that maximum right now. Initially, scientists at NASA and NOAA predicted that this cycle, solar cycle 25, would be pretty weak, a lot like the last one, which was the quietest in a century. But the sun often has other plans. Solar activity has ramped up much faster and more intensely than anyone forecasted. The number of sunspots, those dark, magnetically charged regions on the sun's surface, has already blown past the predicted peak. These sunspots are where two of the most powerful events in our solar system are born: solar flares and coronal mass ejections, or CMEs. A solar flare is a massive burst of radiation, a flash of light so intense it can disrupt radio communications on the sunny side of Earth within minutes. Just recently, on May 14th, 2025, a huge X2.7 class flare erupted from the sun. It was the most powerful flare of the year, and it caused major radio blackouts over Europe, Asia, and the Middle East. It's a sharp reminder of just how vulnerable our technology is. But as dangerous as flares are, they're often just the opening act for something with much bigger consequences. A coronal mass ejection. A CME is when the sun throws out billions of tons of solar plasma and magnetic fields. A giant cloud of charged particles traveling at millions of miles per hour. Unlike a flare's light, which gets here in 8 minutes, a CME can take 1 to 3 days to cross space and hit our planet. And that's what has scientists so concerned. The same sunspot region that's been spitting out powerful flares is now turning to face Earth, loaded and aimed right at us. If it lets loose a major CME in our direction, the results could be devastating. To really get a handle on the danger, we have to rewind the clock. Not to the last solar cycle, but all the way back to 1859. The world was a very different place. The Industrial Revolution was chugging along on steam and the telegraph. It was into this world that the most powerful solar storm in recorded history struck, the Carrington event. In early September of that year, an astronomer named Richard Carrington was observing a huge group of sunspots when he saw an intensely bright flash of light. Just 17 hours later, an incredibly fast trip, the CME from that flash slammed into Earth. What happened next was unlike anything seen before or since. Telegraph systems across the globe went completely haywire. Sparks flew from the equipment, shocking operators and even setting telegraph paper on fire. Some systems were so supercharged with the storm's energy that operators could disconnect their batteries and keep sending messages using just the power from the sky. But the most incredible effect was the aurora. The northern and southern lights were so bright and moved so far from the poles that people in the Caribbean could read a newspaper at midnight by there. Glow, miners in the Rocky Mountains woke up and started making breakfast thinking it was dawn. It was a global spectacle. In a world without power grids and satellites, the Carrington event was mostly a weird curiosity. But what would happen if a storm that big hit us today? The answer is pretty terrifying. Noah Rawafi, a top scientist for NASA's Parker Solar Probe, says the real impact is almost beyond our ability to comprehend. Picture this. It doesn't start with a bang, but with a strange, eerie silence. A giant, Earth-directed CME erupts from the sun. A couple of days later, it arrives. The first casualties are in orbit. The wave of particles hits our planet's magnetic shield and fries the sensitive electronics in our satellites. Instantly, huge parts of our global communications network go dark. GPS signals, the invisible backbone of the modern world, either vanish or become completely unreliable. And that doesn't just mean your car's navigation dies. Airplanes lose their main guidance systems. Global shipping can't be tracked. Financial transactions that need precise timing start to fail. And even cell phone networks begin to break down. But that's just for starters. As the CME slams into Earth's magnetic field, it creates powerful, uncontrolled electrical currents in the ground itself. These currents surge into the one place they can travel easily, our massive interconnected power grids. The transformers that are the heart of our electrical system weren't built to handle this kind of raw DC current. They would overheat, strain, and then, one after another, they would blow out. This isn't a simple blackout you can fix by flipping a switch. These are custom-built machines that weigh tons. You can't just repair them, you have to replace them. And we don't have a big stockpile of spares sitting in a warehouse somewhere. The result? A cascading power failure across entire continents. Tens, maybe hundreds of millions of people would lose power, not for hours or even days. We could be talking weeks, months, or in the hardest hit areas, maybe even years. Think about what that really means. No lights, no refrigeration, which would lead to massive food shortages. No running water, because the pumps that supply our cities would stop. No transportation, because gas stations couldn't pump fuel. No internet. No financial system. No healthcare, as hospitals would be completely overwhelmed and their backup generators would eventually run out of fuel. It would be like falling back in time. A sudden and brutal shutdown of almost everything that makes modern civilization work. The economic damage would be in the trillions of dollars, but the human cost would be impossible to measure. This isn't a movie script. It's the sober assessment of scientists and government agencies who study this for a living. This is the risk we're facing as the sun ramps up to its peak. As scary as that scenario is, we aren't just sitting ducks. Around the world, a dedicated group of scientists are our watchers on the wall, constantly keeping an eye on the sun with some incredible technology. Their first line of defense is a fleet of spacecraft, especially NASA's Solar Dynamics Observatory, or SDO. The SDO watches the sun 24/7 in different wavelengths of light. This lets scientists see the complex magnetic fields and bubbling plasma that signal a storm is about to erupt. This is how we get the classifications for solar flares, on a scale of A, B, C, M, and X, with X-class being the most powerful. An X-class flare is a huge deal. When a potentially dangerous CME is spotted, information is sent straight to places like NOAA's Space Weather Prediction Center. Is WPCC in Boulder, Colorado. You can think of them as the National Hurricane Center, but for storms from space. They analyze the speed, direction, and magnetic field of a CME to predict how bad the impact could be here on Earth. This warning system is absolutely critical. With enough of a heads-up, anywhere from a few hours to a couple of days, utility companies can take steps to protect the power grid. Satellite operators can put their spacecraft into a safe mode, and airlines can reroute planes away from the poles where radiation is strongest. It's a race against the clock, but every minute of warning helps lessen the damage. So, where does that leave us? The sun is active, and the threat is very real. That volatile sunspot region is still a concern. And as we approach the solar maximum in 2025, the odds of a powerful, Earth-directed storm are going up. Even though the cycle was originally predicted to be weak, it's been consistently outperforming those forecasts. And history shows us that some of the biggest storms can happen in the years right after the peak. The alarm scientists are sounding isn't to create panic, but to push for preparedness. It's a wake-up call to recognize just how dependent we are on fragile technology and to work on strengthening our defenses. The sun gives us life, but it also demands our respect. We live with a star, and that means we live with the risk of its incredible power. The next major solar storm isn't a question of if, but when. By understanding the threat and supporting the scientists who watch over us, we can make sure that when the sun does make its next move, we'll be as ready as we can be. To keep up with the latest on space weather, you can follow NASA and NOAA's Space Weather Prediction Center online. Knowing what's happening is the first step to being prepared. Thanks for watching. Please subscribe to watch more as we post new educational video.